Hey everyone, this is Bill Kennedy at Go Miami. We have our second talk tonight with Richard Bucker. Bucker, who's, did I say that right?
Yep, you're good.
Who's going to talk to us today about configuration as Go. Again, I just want to thank our sponsor, SendGrid, and Venture Hive for allowing us to host this event tonight. Hi, Richard.
Bill, nobody has screwed up my last name since, I don't know, high school. So, all right. Anyways, so this talk sort of was inspired by a number of historical events. It was originally called configuration as code. The notion is that when you're building configuration systems, that you represent that in a code format. So let's get started. This place is great. I'm a technical guy, so I'm giving them props. By the way, I was working on these slides just before the 6 o'clock hour, I guess. I was once a rock star programmer. Actually, I was a rock star, and then I was a programmer. Of course, it was just a garage band, so now you know more than most people do know about me. I started programming in the 80s, and my resume is about as long as it gets, so we don't need to talk about that. Is anybody here using Chef, Puppet, Ansible, maybe, SaltStack? Okay. These tools are used predominantly for configuration management. It's when you're moving your code into production, if you want to configure web servers, configure applications, pull down resources. It's the idea of making your installations idempotent. Same thing every time. But I hate DSLs. I hate DSLs with a passion. They seem to distract you from the work that you're trying to do. So while Puppet and Chef are Ruby, Ansible and SaltStack are Python, but if you're writing Go code, then they sort of get in the way. And it means that you have to learn yet another syntax. So the inspiration for my project came from spending some time with flow-based programming. And most of the current flow-based programming is taking place in JavaScript. I implemented a model, a proof of concept in Go. I unfortunately used a lot of reflection, but that's the sort of thing you have to do to get some of that flow-based programming to work. Paul Morrison's book is an awesome reference. The NoFlow and FlowHub guys do a great job of presenting flow-based programming. And then, I guess it was last year sometime, an internal presentation at my company did a configuration as code presentation using Puppet as the demo language. And then I'd also spent a number of years working with Fabric and deploying my own applications and getting distributed systems to orchestrate and coordinate. In particular, trying to reboot 100 machines at a time. Fabric is awesome for that. But I made a number of observations. Some of the key observations is while they work, and they're free, but they're basic. When you use Chef or Puppet, the very first versions, you might be able to, if you're lucky, be able to instantiate or create a user account. If you want to do anything more complicated than that, you're writing more code. When you get beyond the free versions and you start paying for Puppet and Chef, you now get a little bit more free code from them in terms of libraries. You get a bunch of support, but you still have to write a lot of code yourself. And if I'm going to write a lot of code myself, I want to do it in the language that I'm engineering for. Because those things require a lot of code, you're going to make mistakes. The mistakes translate all the way down your stack. In fact, one of the pieces of code I was looking at a couple of days ago, somebody wasn't checking return values, and now we have a situation where there are only a number of, we have a fraction of the number of successes to the failures based on not checking result codes. And of course, there's no rockstar points for repeating yourself every time you have to copy and paste a library. So in the orchestration toolbox, there's a number of use cases. You can think of Chef and Puppet and these guys as installers of sorts. In the first use case, you bundle up your source and you pass it on to a system and you say, do this. So you have this solo application. There are no external resources, but you have a bunch of Ruby dependencies. In some cases, you can push. You can take your snippet of code and pass it off to a server and say, execute this little script of things and tell me when you're done. You can have applications that are running as daemons, and are pulling change requests or even triggering off of get received. And so they'll be waiting for events to occur that they have to react on. And then finally, there's the continuation one. And that model is particularly interesting in Puppet. And what they're looking for there is they're looking for changes on the host. You have a Puppet daemon that's running on every machine. It knows about the system, and then it attempts to correct changes to go back to that known state. So if you log into a machine that's being monitored by Puppet and you make a modification to the host file, if it knows that the host file changed, it's going to revert it back to its previous state. I think it was Red Hat used to do that on some of their config files back in the early days. They used to manage the consistency of all of the configuration files in the etc directory. So, you can implement these things, these installers, with shell scripts. You can even go into the continuous sort of solution by setting up a watch and watching for an event and then executing your shell script over and over again. And when it comes down to it, that's really all it is. I mean, but you're dependent on the shell script. You're dependent on something that somebody can modify on the fly. If you're running an enterprise, you don't want these files to be modified remotely. You want them to be consistent from your repository of sorts. And you want them to be idempotent. And Bash doesn't do that very well. It takes a lot of effort to make sure that the outcome of your scripts are idempotent each time. And if you've ever written TDD, you can really get wrapped up in making sure that you pass or that you've tested every branch in every statement. So all your ifs, all your whiles, everything has to be tested. So that can get a little bit hairy here. And of course, the last thing on the shell script, you can always exit your shell script with a set E. So the first error and you're going to pop out. That doesn't always guarantee the best effect, especially if you're modifying passwords or certificates. So in my particular project, which I call the Installinator, I wanted to move it into sort of a DSL, even though I hate DSLs. I still hate DSLs. But in this particular case, I said, well, why don't I just use JSON? The libraries that come with Go are awesome at marshalling and unmarshalling JSON documents. They get a little hairy with trying to trap errors and tell you where the errors are. But the decoding and encoding of streams rather, make it a lot easier so that you can take these structures and find the spots where the errors occur. So this shell example is rewritten in the JSON version of that. At this point, JSON is starting to look like a DSL, but the framework is something that we all understand. It's not like you're actually learning something brand new, like this is not Ruby. So the questions I find myself asking myself all the time is, should I use my continuous integration in the same language that I'm writing my applications? If I'm splitting my mind share between Ruby or Python and Go, am I doing myself a disservice? Making that context switch in production can be a bit of a challenge. And then if I'm going to build a DSL for my version of continuous integration, would I want to use conditionals? Because when you get back to TDD or BDD, conditionals mean that for every conditional you have to have an extra test case. And while I hate test cases, I also love them because they save my butt more than once. So Go. Some of the things I like about Go, it's static linking. Unlike some of the dynamic languages, you pick up your executable, you move it someplace, you can execute it. With its cross-compiling, it's even sweeter. In one particular case, I have my current desktop is a 64-bit Mac, but I'm publishing to a 32-bit Windows. It's seamless. File namings is helpful. So you don't have to actually put any conditionals in your code that says I'm compiling this module for Windows, I'm compiling this module for Linux or Unix or Plan 9 or Solaris. The file system hints to the Go compiler exactly which files to select for the target operating system. The transcoding, it's awesome. They'll even support XML. In the transcoding, you'll provide a structure, and inside that structure, you'll provide tags, and inside those tags, you'll tell it this is the name of my column for my JSON document, and this is the column that it belongs to inside my structure. So translating is almost seamless. And then reflection. Reflection is tough no matter what language you're writing them in. It does take a deep level understanding of the data structures. The point between the language, the compiler, and just the first layer inside the internals of the compiler. So the installinator got refactored, and I created something called the macroinator, which became a variation of a DSL. Again, I still hate DSLs. In this particular case, I was looking at trying to simplify my model. It became way overcomplicated. There were compilers and runners, and at some point I got to about 130 verbs, and they all started to look alike, and then I ended up copying and pasting between every file. It just became a lot deeper than I wanted to be. And I was also losing control of the knowledge base that I had in the code. It wasn't looking like something anybody would ever want to contribute to. So unlike Mark's presentation where he was talking about lightweight, this thing was getting very heavy. Configuration as code. One of the things that I like to do in my code is use makefiles. The Go guys don't typically like makefiles. They like to think that the build tool does all the work for you. But sometimes you need to know things about your code. You need to know which dependencies you have and how you're going to load those dependencies, and making sure that if you're doing vendoring, that they get placed in the right location. So for me, I like to put all of this knowledge in makefile. It's the equivalent of a README file, but it actually does some work. So keeping the makefile simple, not going into the anybody used AutoConf or the AutoConf tools? Those things will drive you crazy. I mean, trying to figure out, dependencies between dependencies all the way down the path. I just want to keep things simple so that I know how to create my environment idempotently between runs, whether I'm working on this machine or that machine, and carry the differences forward. So in the install tool, what I was looking for is, well, how do I define an action? If I need to get some work done, whether the work is copying a file or testing to see if a file exists or downloading a file off a web server. So let me define what it is to be a macro, or at least what it is for that task. In this particular case, I'm looking to register. I've got this first array of interfaces, which is a collection of definitions of all my macros. I'm using interfaces because I'm heavy on reflection here. The register macro is the opportunity for me to register this macro with this global definition, this global namespace. And then here's a sample verb. It's just a false. It's meant to return false no matter what it does. At the top here I have a structure which defines generically the false verb. And if you've ever done, I didn't actually count the number of hands that went up on Puppet and Chef, but with these install tools, you typically have a small definition, and within that definition there's a wrapper of meta parameters that are shared among all the parameters. So this first field is this false structure is the meta parameters, and this is where I store all of the common parameters, the name of the particular function, whether or not I'm stopped, what the previous error was, whether I'm going to stop on errors or continue, what the particular timeouts might be, for example, if you're doing a download of a file. The second structure is a convenience structure. Go does not support, well, it supports nulls, it supports pointers, but it doesn't really support either of them in a nice way. You have the notion of a zero value is something that you have to really work hard to determine whether or not a field has a zero value. But arrays are always pointers. So in this particular case, I'm saying I'm declaring a wrapper, a false wrapper, which wraps my false structure, which is this structure up here at the top. And I've decided that this is always going to be an array of false instances. It's defined with a JSON tag of a false, so when I'm marshalling in and out. And then I'm saying I'm going to have one or more instances in my array. So I'm setting the min and max range for the number of elements in my array. This will show up in the next couple of slides again. But the reason for that is because if I just had think I can, yeah, if I just had this, forget the recursion of the data types, but the false structure up here can't be null. It will be empty, it will have a 0 value, but it can never be null. If I do that, then this value can have a null value, or a nil value, actually. Does that make sense? Did I lose everybody in my own little, my own calculus sometimes goes crazy. So the third element here is the work that gets performed in response to what this task is. In this particular case, we're returning false. And then every function, every file where I describe a particular method or verb, I'm also registering it with the macro definition in the previous slide. Just look back here real quick. There is a registration in the middle. All right, am I going too fast, too slow? Anybody feel her? Okay. So here's a slightly more complicated or an incremental leap from the previous one. In the previous example, we had false. In this particular one, I'm saying, here's my root file system. Typically, when you're doing installations, you're going to want to know where is root. Not to be confused with web server's root, but if you're going to install an application with a bunch of subdirectories, where does that begin? So in this particular case, I'm just saying, here's my structure. I've got a path, and the field is required, and this is where I know that in my file system, this is where I'm going to store my goodness. And then again, I have my wrapper class. I've described my JSON tag, and I'm saying there's one and only one of these. And then finally, initializing or registering this particular verb with the macro definitions. A little bit more complicated. This particular verb is going to do a copy. So now you need to know the source, destination folders. They're relative to the root file system that I mentioned in the previous slide. Whether it's recursive, and whether or not this is where you can get a little deep with looking at the grammars that go with configuration management systems. Does the file exist? Will it? Should it exist? What happens if it fails? So I try to keep it simple for the sake of this and for the proof of concept. So there's a test here. The source file has to exist. If it doesn't, then we're going to throw exceptions. Then there's the copy wrapper, as in the other cases, and then the initialization. But what's missing here is the actual work. So this is my copy Go file, but here's my Unix version. And in my Unix version, I'm spawning out, doing an exec with a cp command. Here's my my do func. Let's see, where's the actual exec? This will spawn, sorry, this is the exec command. There's actually another class called exec where you can exec command line things, so it's also provides some nesting. But there would also be a Windows version of that as well. So if you're copying files of Windows and wanted to spawn out to the copy command, the COPY, as opposed to CP, then you'd provide those deltas in the actual verbs themselves. Test cases. So here's a working test case for false. This uses the Go test structure, or a tool rather. And in this particular case, I have my document, which is the JSON document of the thing that I'm about to execute. I got a little deep with this, and I decided, well, let's have a configuration section, a start section, and do a little bit of work, and maybe some more work, and then an epilogue. So if things go wrong, you can sort of, within the framework, specify, well, if you can't pass the config, then at least run the end code so that you can close any things that you've done, or extra resources that you might have opened, or files you might have copied, or just clean things up. And then across just about every single one of my test cases that are testing code like this, or code samples, there's this little snippet piece of code which does a compile and an execute, and then checks the results. You can get really exotic with this particular piece of code. There's a good tool called GenMox, and GenMox gives you an example of how you can compile code for test. So it does a little bit of that Go generate stuff, which showed up in 1.4. So it's kind of fun. I haven't gotten that far yet. So Here's rootfs. I'm setting some values. How am I doing on time? Okay. A different copy test, which again, just a document, going to run it, compile it and run it. But then I took a step into the weeds, and I started really getting into the code, the Go generate stuff. And what I just started to discover was a couple of things. First of all, given some environmental data, well, let's take a step back. So what we're doing, right? We're making a configuration tool. You're going to take some compile time information, some environment variables. You're going to wrap it up all into a single executable, and you're going to copy that executable over to a server someplace, and you're going to execute it and expect something to happen. You're going to expect a web server to come into existence or a mail server to come into existence. You're going to do something with this code. But what you don't want to have to do is copy the configuration information at the same time with the code. You don't want to have to go to that machine, set up some environment variables, and then launch a program and then have all of these things take place, because you want this to happen in seconds. You don't want to have to think about it. You want every time that you launch this configuration tool, you want your systems to be in a known state, especially if you're using something like Amazon or Google Compute Engine. When these environments come up, you want to know that you're going to be healthy. So I started looking at Safekeeper. Safekeeper was originally designed with this notion of when you have an Amazon product or Google, you get these keys, these super secret keys. You're not allowed to tell anybody about them. And if you put them in your global repos in GitHub, somebody's going to steal them from you, and you're going to get, your budget's going to be blown in about a minute. So what this guy suggested was, well, let's use the Go generate thing. Let's use some templating, and let's move these environment variables into your actual code. Let's pull it in. Well, I took that a step further, and I said, well, when I'm compiling my code, I need to know, when did I build that code? What was the last git commit statement that I used? And when did I build it? And maybe even where did I build it? So for me, what I've done is I have this, starts off with an empty file. And in that empty file, I've got, I'm going to pull some values in from my environment. And the three values that I've chosen here are my git tag, my build timestamp, and my app name. And when I'm running my app, I can dump the help or the version information, and it will spit that out for me. When I'm looking at my logs at the end of a build run, I'll see that these were the versions of the things that I've run. So now I've got some audit and some compliance support on the back end. So the first artifact for generating is having this particular file. It's an empty file. It's got a package main. It's got the Go generate in the first comment. The second part of it is a template file. And in this particular template file, you're just marking it. You'll notice that it has a .safekeeper tail suffix on the file. This is non-executable. The Safekeeper toolchain is going to grab this file, substitute all the template values, and then spit it out according to the signature right here. Okay? So we have these three templates, or these three variable names, git tag, build timestamp, and app name. In our file, we've prefixed env underscore app name, git tag, and so on. So now when I do my Go generate, my Go build, these values will be pulled from the environment and then substituted back into the code. I'm going to zip back to the make file very quickly. If I can find it, it's right here. You'll notice that in the first line here, I grab the tag from Git. I grab the timestamp, including my name, because I'm the one who's doing the compilation. And then I've also assigned the app name. And now when the Go generate executes, which is a dependency, let's go, it's all the way down here. When this runs, it's going to pull in safe main.go. It's going to see the / go generate. It's going to pull in the safe main.go / safekeeper, and then export main.go, which would be the compiled version with all the values substituted properly. Let's see if I've got one of those. No, you know what, it's right there. Here it is. So here's the substituted values. And you'll notice that it also is kind enough to tell me don't edit the file, because it's going to change. This is actually very valuable. If you've ever had an executable and you've looked at the file the file create date to try and figure out when you built it, but you've copied the file from system to system to system, only to realize that the timestamp got changed every time you moved it from system to system. This is the only way you know where it was. The best part, of course, is the git tags, so that you can now figure out which change set that was. You know exactly what went into that package. Well, this is only a part of the list of the installinator. I got crazy with the verbs. I didn't even implement more than about 3/4 of them. They were all namespace holders. It became part of a to-do list. But there's, it's reasonably complete. The number of verbs that I chose or macros that I chose were based on the aggregate of Chef and Puppet. If I ever get it finished, it's actually going to be quite useful. Safekeeper, yeah. Bad news is it depends on Kingpin. And to Mark's credit, he makes a very good point. Choose libraries that are thin. At some point, you'll be expected to know how they work, because when things go south, you're going to have to fix them. So stick to the ones with the smallest code trees. In this particular case, Safekeeper depends on Kingpin, so I refactored the code, forked it, and then pulled all that Kingpin code out. Kingpin is just a command line tool, much like flags. Anybody use flag? The command line parser tool? Okay. So flag is a way to parse the command line in Go. It's perfectly adequate. There's no reason to get into any of the complicated stuff that some of the guys are writing out there. And so when they used Kingpin, they didn't use it for anything complicated. It was just probably because they were used to it. But I didn't like the nested dependency. If you're building software for anybody with PCI or HIPAA requirements, you really do need to know your tool chains. And so, you know, third parties can, in fact, stick stuff in that make your life hell, leak data. You don't want that to happen, so I pulled out what I didn't need. As I said, I hated DSLs. I still hate DSLs. It still hasn't changed. There are 3 major projects in the works on what I'm working on, or which have my focus. The Installinator, Macronator, and the Goose. The Installinator was the first attempt at building configuration as code. Macronator was a much more refined look at how to improve that code so that it was reusable. Goose turned out to be how to use DSLs. I had to choose a DSL at some point. I said, you know, I'm writing this JSON document. It works great. I mean, but who really wants to sit with a JSON editor and write code? You know, maybe I need to get it to a little bit more modern. I'll talk about that in a moment. A couple other tools that I wrote. One's called Golo. It's essentially stands for Go Local, and that was before I started having a hatred for projects with Go in their prefix. Yeah. If you've written it in Go, it's obvious, right? I mean, you know, but in this particular case, it stands for Go Local, and the idea is that anybody familiar with vendoring? Okay, so vendoring is this notion of capturing your dependencies, but embedding the dependencies in your project directly, so that if you were, let's say, pulling in some Google libraries for calculating pi, if you knew that you were dependent on version 1.0 of that particular module, you'd want to make sure that that package was in your source code. So you use this notion of vendoring. Well, Golo allows me to, from my build directory, find my local vendors. Oh, sorry, yeah, find my local vendors. The complication for vendoring is you have to use something like GoDeps. It's a package for finding your dependencies and storing your dependencies locally. Golo will automate that process for you, so it'll build your Go path and make your actual Go build a lot easier. And finally, Lockfile was just sort of a whim. Anybody used FSLock on Linux systems? FSLock is a standard library, standard function rather. Its purpose is to create lock files inside of batch files so that you don't run more than one instance of a particular thing. I figured, you know, life was too short. We needed to have a Go version of it, because when I'm looking at code and libraries and applications, I have an affinity towards Go. If the code's written in Go, it's available as source. I'm just naturally gravitating towards it. So Lockfile didn't exist in that format, so I built it. And I don't actually use it because I don't need it, but it was just for fun. So Goose started off as I hate DSLs, so let's go ahead and build a DSL. But I wasn't going to build a DSL. Anybody who's actually built a DSL or built a custom language goes back to programming 101 when you learned your first compiler writing class. I said, there's no way. There are too many general purpose DSLs out there. Why am I going to build one? So I started off with Tcl, TCL, and I said, well, let me see if I can embed TCL inside Go. And in fact, there were some other libraries, some guys who had done some work. Now, these things fall into two categories. There are those who found ways to take the C version of these tools and embed them directly inside of a Go application. And then there are guys who wrote, guys or girls, wrote interpreters directly in Go. My goal was not to embed Tcl, Lisp, and Lua, C binaries into Go, because that was sort of a pollution. It really wasn't what I was looking for. I was looking for a DSL. I need to be able to have a verb and have some parameters and actually execute some work. So in 2 consecutive evenings, I was able to get the interpreted versions of TCL, Lisp, and Lua. I liked Lua for one particular reason, and that is, when you're trying to hire people, game programmers, especially for testers, right? Game programmers and testers seem to be really closely aligned. So Lua is a great tool for that. World of Warcraft uses all of its leveling in Lua. So that was some cool dual purpose. If you want to hire smart people, they say, do everything in Erlang or in OCaml, but Lisp is a close second. A lot of the smart guys from MIT and Harvard like to rant about their Lisps. And fortunately for me, Tcl is just simple. Tcl is used in a number of Cisco devices, Cisco routers for naming rules. So these seemed like the low-hanging fruit. Perl, Python, and Ruby were all potentially interesting, but their grammars were so complicated that you really did have to use things like Yak and Lex and produce compilers. And that became a much bigger struggle than I just want a simple parser. And all three of these languages provide that. Okay, so now you have this ability to parse. There's a grammar or a dictionary, and then for every event that you want, for every function, like a print statement, you have to turn that into some realized code. Well, each of these languages have parallels. No, I don't have any code for that. So for every, let's say, in Tcl, the command is puts, P-U-T-S, put string. And what that does is it writes to the console. In Lisp, so essentially I've got a function that says, in Go, func put s, and then provides some parameters, and then underneath that is a funct print line, or a funct printf. In Lisp and Lua, there are analogs for that. I think in Lua it's print. I don't remember what the Lisp one was. I think I had to manufacture that one. So now I've got all of these analogs of language primitives and internal Go functions that do the work that each of these functions need. But what I saw was an explosion of functions. I saw for each language I had to create a primitive verb. So let's say there were 10 verbs, print, get, multiply, add, so on, 10. But now on the inside I had to have 10 functs that would actually do the work. Well, because each language had a slightly different method signature, I ended up with close to 30 different functions and 30 different verb definitions. So I've got to find a way to pare that down. Step back to GoGenerate. GoGenerate will actually allow you to parse your own C code, will allow you to look at the call tree, that's it, the function call tree, the internal representation of what your code looks like. Much the way you would use reflection, you can reflect on your own program, and now you can start to generate additional code, which will allow you to add shims to all of this stuff. So here I have my 30 verbs. Here, instead of having 30 functions, I'm going to have 10 functions, and I'm going to use GoGenerate to stitch the two together so that I can span, or connect rather, the internal workings of the different interpreters with the internal version of all of my actions, my libraries of tasks to do. Now, why was this particular thing important? Well, I was building WebDriver. I was building the equivalent of Selenium. Anybody use Selenium? Oh, man. So my interest was to effectively replace Selenium. Selenium's a pain in the ass. The very first failure that I had was, hey man, my code crashed and I'm leaving sessions up. So I had to look at ways to try and kill my Chrome and Firefox sessions. Got around that. So now I was discovering, hey, I can allow testers to come from anywhere and build in their own native tongue of Tcl, Lisp, and Lua and build interesting test cases. So now I look at this and I go, wow, I can do browser testing, I can do installation with the installinator and that orchestration stuff, all in one package. Now I can move my code into production, launch my web server, and test my web server to make sure that the web pages that I expect to see are there before I even promote this thing or provide my floating IPs to my routers. Now, if you're building thousands of these servers at a time, they can test themselves before they ever get to production. In some of the larger installations, you'll see 30 and 40,000 machines, and you're just not going to be able to test them all. It's got to be integrated into your deploy scripts. So now we have that one executable going to that one location. Flow-based programming, I didn't even get to that. That'll have to be a topic for another day, I think. Okay, I think this is the end of it. Yes, this is the end of it. So there were a couple of things that were also sort of starting to trickle out of my learnings. The first is sticky wrappers. You've worked with sticky wrappers. I know you have. Damn. All right, sticky wrappers. You should be able to search it. One of the Go authors did a great talk on it. Sticky wrappers are awesome. It could allow me to do interpreted Go. So I've got all this other interpreted TCL, Lua, Lisp. I want to do Go also, so that I've sort of got that recursive thing going on. Sticky wrappers is going to get me there part of the way. It's how you deal with the notion of not having to check your error conditions on every call. So, for example, if you have, you're going to call 5 functions, func A, func 2, func B, 3, and each one is going to return an error flag. Rather than evaluating that error after each call, you can defer your error to, defer is a bad term, you're going to wait to look at that last error till the last func is returned, because each of those funcs is going to know that if there was an error, I'm going to return right away. So sticky wrapper is an awesome way to take care of that. I was going to talk about interpreted Go, which is getting another language into this thing. And maybe, you know, if they ever come up with a compiler the way Java does, then maybe doing compiling on the fly on a remote system wouldn't be an unreasonable thing. Go bin data, is another great tool. You know, Mark needs to add Go bin data to his list of things. We'll talk about that later. When we publish this list, this slide deck, you'll see that there's a number of links and references to things. Paul Morrison's an interesting watch if you can watch some of the interviews with him. His ideas for flow-based programming go back to the 60s, and they're awesome. I work for Ultimate Software. We're hiring. We're always hiring. That's it. Thank you very much for your time.
Anybody have questions?
Yeah, I mean, you're doing this for, like, just, you're not satisfied with what's out there.
My inspiration was, if I'm going to write Go code, I should have a Go installer. Chef and Puppet work best in environments where you're a Ruby programmer, where you're a Rails programmer. Because when you're installing your Rails or your Ruby application, you're already bringing with you all of the dependencies of all the libraries. Also, if you have a Rails application and you need to copy a file, why wouldn't you use some of the libraries in your Chef or Puppet libraries? So if I'm a Go programmer and I want to write Go programs and reuse as much code as possible, if I'm building a library that's going to copy a file, I wouldn't want to do it in Chef or Puppet. I'd want to do it in Go so that I can leverage it once, test it once.
The idea that this program, you can run that on that virtual machine, is everything down?
Yes.
And have that configuration.
Yes. Take a bare metal machine and have it become something.
And everything is in that file. There's no other files in the file.
Well, Go generate is going to is a part of a code generation set. So normally when you're building code in Go, you'll type Go and then build or Go and install. in reality, it's the steps are go generate, go vet, go test, maybe go lint, and then go build. So there is actually a proper order or an idiomatic order for these steps. The go generate is just taking some template files and generating some code for you that becomes stubs and things you might have. Go generate is also part of a lexical analyzer that's built into the language. So if you were going to generate code based on code, the perfect example that I saw was SourceGraph. They're a code parsing company, and they wrote a project or a module called GenMocks. So if you've ever done these mocking of data sources, the notion is if you're going to test a particular function that does a particular behavior, you want some sample data. You're not going to want to actually go out to the database to retrieve some of those, because now you have to create databases that represent all of the states of all of the things you're trying to test. So what you might do is, instead of having access to a proper database, you use a mock, which is a simulation of the data set that's coming back. So you might have a simulation of an empty set in a mock. Well, the guys over at SourceGraph found a novel way to use GoGenerate to parse a particular file, parse actual Go code, to generate a data structure that represented the Go code, and then to inspect it going, I want to take all my functions that have a suffix of service, and I want to create a template for a mock. This way, they only had to create it once. They could use this one, by inspecting the original source, they could produce the elements that they were missing. In the example that I gave, I needed a shim between the actual verb definitions, the notion, the 10 different verbs, the 3 different languages, all talking to the shared library. But the function signatures, the shared libraries, were internal to me, not shared with the individual language interpreters. So that shim had to be generated dynamically through GoGenerate. The only way that would work is GoGenerate looks at my libraries, looks at all of the signatures, and then refactors them to provide that shim layer between. I hope that's clear. It's interesting. GoGenerate is very powerful, and I've only scratched the surface. Cheney did the last demo that I saw, and it just blew me away.
A lot of people are worried about people using it. So it's
yeah.
So is Ultimate Software using Go, or weren't you guys a big .NET shop?
We are predominantly a Windows shop. We're making some changes. There are groups that are working in Go. I personally have deployed 3 programs to production written in Go.
Awesome.
So now that you have this installed in a Macrometer finally, and you have 10,000 servers, how do you get it to all 10,000 servers? That's a whole other problem.
Well,
it's going to be at least a 5 meg binary. 10,000. That's pretty low advantage.
Yeah. I mean, the thing, if you're going to install 10,000 servers, for example, there is a delicate dance that takes place. First of all, if you're using something like CoreOS, or OpenStack, you're going to have a config.init file, and that config.init file is going to sort of preempt the operating system. It's going to say what the basic features and functions that you're going to execute during startup. So in this particular case, I'm looking at having the installinator launch as a daemon sitting on each of these machines waiting for work to show up. The other part of it is very similar to Fabric, and that is, well, let me send over some code. Here's my DSL. I've got some code I want you to execute, so here it is, go do it. Sending that to 10,000 servers is easy. Waiting for it to complete is not. Additionally, if I'm going to do that bootstrap during Cloud.init, since this is a multi-mode sort of application, when it first comes up, it's going to go, hey, I'm alive. Number 5, I'm alive. Let me find out if there's any work I need to do. Based on what I'm supposed to do when I start up, are my users in place, are certificates in place, let me create those, modify those. And then when that part finishes, now start waiting for commands from Mothership, and then execute those steps. Or listen to Git receive, too, that also works.
All right.
Thank you.